Oh, so rude on a Monday. You guys are too much.
Wait, what's happening?
Hey, and I leave it me calculator.
Oh my
Just,
god.
you're already up, you know?
I guess.
Okay. All right, so are we ready? You need a calculator? You must have. Where's the please?
Please, no, it's like a meme.
Huh? Oh,
We've lost
like
all
short
manners
calculator.
today.
oh. What?
It's a meme, it's a.
It's a mean to get me a calculator?
No, the thing, bro.
It ain't not me.
I don't think we're doing
I
that.
actually have no idea what's happening.
that.
Okay, listen, I do have something very important to tell you. Very, very important. Huh?
If you say no, no.
I'm having another baby. No, that's not it. Okay, listen, I had to pick one class for Miss Reams to come in and observe, and I picked you guys for Wednesday. So what that means is that you need to not have your phone down, not today, but on Wednesday, you need to be the best version of yourself. She's only gonna be in here till lunch. But we're gonna do vector application problems, so by then you have to know what a vector is. So, have y'all seen vectors? No? Yes, you have.
No, we haven't. I don't know what that word is.
You've never seen a vector?
No.
Alright, that's okay. Alright, so let's just do what a vector is. It is an arrow. Okay, so draw a little arrow here. You do? Okay, good. Okay, gentlemen, are we ready? Practicing for Wednesday, when you're gonna be the best version of yourself.
Who's Miss Reams?
She's my principal. She's the little one that plays music at the door where you all walk in.
The little one that plays music.
She's blonde. She's lovely. She's wonderful.
That's nice.
Okay. So a vector is an arrow, but there's one big difference. When you were in geometry, do you remember that we called this array?
Yes.
An
Yeah.
array goes on forever and ever and ever. A vector does not. So read right here. It looks similar to array, but it has a finite length, not infinite. The starting point is called the tail. And the terminal point is called the head. So if you will label on your vector, this is the tail, this is the head. Okay? And so since we're introing to vectors, we're gonna start off just by explaining what they are. You're gonna have a horizontal component and a vertical component. Okay, which is very similar to an X and a Y. Okay, but the notation, the one thing that's.
Something's gone wrong.
Oh, sorry.
Please try again.
Okay, but one thing that is different is that if it's an ordered pair, like an X comma Y, you use parentheses. If it's a vector, do you see how you have kind of like little pointy parentheses? Okay, so that shows that this is a vector, not an ordered pair. Okay, so we're gonna graph a couple of vectors. This should be very few brain cells required. Okay, first one, it says vector A is 2, 4. Pick a starting point. I'm gonna put mine here. Okay, doesn't matter. And then if my 2 is my horizontal component, I'm gonna go to the right 2. And then 4 is my vertical component. I'm gonna go up 4. 1, 2, 3, 4. That is vector A. And the symbol for a vector is almost like an arrow, but you cut the little bottom piece off. Okay, let's do vector B. Here we go. B is -6, 2. So pick a starting point. I'm gonna put mine over here. And which direction do you think we go if it's -6, 2? To the left 6, very good. So 1, 2, 3, 4, 5, 6, up 2. And that's vector B. And then you just put the little half arrow with the bottom tail cut. Okay, last one is vector C is 5, 0, pick a starting point. And then 5, 0, I would count to the right 5, that's my horizontal component, 1, 2, 3, 4, 5. And then if my Y is a 0, that one's gonna cut straight across, it's not gonna go up or down. Okay, good enough, easy? Okay, let's get into operations. There are only really 2 operations that we're gonna cover today. The first one is gonna be multiplication. So let's fill in the blank here. Vectors can only multiply with what's called a scalar. And a scalar is just a fancy word for a number by itself. So for example, you can multiply a vector by 5, you can multiply a vector by 6. What you cannot multiply a vector by is you cannot multiply with another vector. Okay, you cannot multiply vector A times vector B, that doesn't make sense. Okay, but since we can multiply them with numbers, let me show you how easy it is. If I want 3 times vector A, it would look like this. You would say, okay, then I want 3 times vector A was 2, 4. Notice that my parentheses are pointy because this is a vector, not an ordered pair. And then all that you're gonna do is take that scalar times it by both components. So my 3 times 2 would be a what? 6. And then my 3 times 4 would be what? Well, very good. Now go up to your grid and we're gonna graph 6, 12 next to the original. So come up here to the top. I'm gonna put my starting point down here. And then I'm gonna count over 6 and up 12. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And then we're gonna label that 3A. So you have your original A and then your 3A right next to it. Okay, when you're ready, we're gonna go on to half B. So half is still a constant, but if I want half B, I want half of -6, 2. Half of -6, 2. And remember, all you have to do is take that half, multiply it into both components, which means what will my new vector be? -3, 1. Then will you sketch that on your grid that originally had vector B on it? Okay, vector B, -6, 2. Half of that is -3, 1. So I'm gonna put my starting point right here. And I'm gonna go -1, 2, 3 up. And that would be half of B. Okay, let's do some observations. When I multiplied A by 3A, it went from this to this. When I multiplied B to turn it into half B, it went from this to this. What do you think the number does to the vector? What does it change about the arrow? The length, perfect. So come down here. If your scalar is greater than 1, your resultant vector is going to get longer. And if your scalar, remember that's just the number in the front, if it's less than 1, your vector is going to get shorter. Okay, then one more blank we're going to fill in right now. If you multiply by a positive scalar, meaning like 3 or a half, your resultant vector should point in the blank direction. Look at your vectors. Did the direction change?
In the same direction.
They point in the same direction, but the length changed. So that last blank we're gonna fill in here is a positive scalar. Your arrow should be pointing the same way. So it'll get longer or shorter, but it's not gonna change the angle that it's pointed at. Okay, let's see if that changes when we use a negative scalar. So take a look at this example. Negative 2c is gonna be -2 times 50. -2 times 50. So what will my new ordered components be? -10, 0. And then remember, you're gonna start your dot at the tail and draw to the head. So if I put my initial dot, let's say here, okay, just picking a spot, then I'm gonna have to go to the left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I have to connect from the starting point to the end. What happened to my direction when I times by a -2? It switched. So your last blank at the bottom of the page there says, if you multiply by a negative scalar, your resultant vector will point in the opposite direction. So if C points to the right, -C is gonna point to the left. So opposite is the last blank. Okay, can we do it? Easy, good?
Yeah.
All right, turn the page, please. All right, so there are two quantities that we're gonna learn about scalars today before we do word problems on Wednesday. The first one is magnitude. Magnitude just means how long the vector is or the length. Okay, this is very easy to find because when you draw a vector, you can basically just do Pythagorean theorem to find how long. Do we remember Pythagorean theorem?
A squared plus B squared.
Okay, very good. A squared plus B squared equals C squared. So let me show you how to do that. Now, even though you can draw a vector anywhere on the graph, it's gonna be usually the easiest if you can just start it at the origin. So my vector V is 8, 2. So even though I could graph it wherever I want, I'm gonna start it here. That way I don't have to count as much. So if I start there, I'm gonna go 8 to the side, up 2. There's my vector. And the question is, how long is that? Well, then all that you're gonna do is make a little triangle with your horizontal and your vertical component. So I'm gonna draw a length here and here, and now I have a triangle. How long is the base of the triangle? 8. How tall is the triangle? 2. Then if I want to know the length of the vector, that's this side here, I can just call it C. So what would my Pythagorean theorem be?
8 squared plus 2 squared equals C squared.
8 squared plus 2 squared equals C squared. Okay, 8 squared is how much? 64 plus what's 2 squared? 4. And then what is 64 plus 4? 68. And then if that's C squared, square root both sides, which means that your magnitude or your length is root 68. Now, let me walk you through the notation for that. So you're gonna do double bars, that means magnitude. So it's almost like an absolute value of vector V. So what that means is the magnitude of vector V. Okay, the magnitude of vector V is equal to root 68. Now, if you turned that into a number, you could know the square root of 68 is 8.24. That's how long it is, but for your homework, you're gonna use this answer. Okay, so I'm gonna put here, that's about the same as 8.2. Okay, but for your homework, it says exact value, so you're not gonna use the decimal, you're gonna use the square. Okay, we're just gonna do one more of these because I feel like you can do Pythagorean theorem on your own. Okay, go to letter C. Will you sketch the vector, please? The vector is -3, 7. So I'm gonna start at the origin. I'm gonna go to the left 3 and up 7. And then if I wanna know how long that arrow is, I'm just gonna turn it into a triangle. A squared plus B squared equals C squared. So bloop, bloop. Okay, what should my formula say? Okay. So 7 squared plus -3 squared equals C squared. What is 7 squared? 49. What is -3 squared? 9. And 49 plus 9 is what? Okay, very good. Now, real quick. Let's say that when you wrote this down, you were like, oh, I'm kind of lazy today. 7 squared, oops. 7 squared plus -3 squared. Okay, I don't get 58 because why? If you put the negative, what else do you have to put when you square it? Parentheses. So if you want to do this, that's fine. Okay, but what would be easier would be just ignore the negative. It's gonna cancel out anyways, so just don't put it. Okay, but if you are gonna put it, you must put it like that. Okay, otherwise the 40 is gonna come out wrong and you'll get the wrong. Okay, then from there, square root both sides. We would write the magnitude, that's your double bars, of vector V is equal to the square root of 58. The square root of 58 is about 7.6, but the answer that you would use for your homework is the exact value. Make sense? Easy? Okay, at the very bottom of the page, you have a formula for magnitude. Okay, all that you're gonna do is a squared plus b squared, then take the square root. Okay, but that is Pythagorean theorem, so if you wanna write it like we did on the notes or use the formula, I don't care. Are we all good with that?
Yes.
Okay, last little bit of this, turn the page. The last thing you have to be able to find is the direction of the vector. Okay, this is a little bit complicated only because when y'all learned all the trig stuff, I wasn't here. What's up? Oh, thanks. You're welcome. Thanks so much. Okay, so draw a little grid up here. And we're not doing the last page of the notes. This is our last page right here. Okay, when you measure direction, I want you to read this right here. You're gonna measure it from a positive angle, and it has to be formed by the positive x-axis, and it has to be measured counterclockwise. So you're gonna always start here. And you're gonna always rotate. Positive angles means this way. Okay, just like on the unit circle. So when you learned the circle, you should have done negative angles, coterminal angles. We're not going back to that. We're only looking at 0 to 360 measured from this start point around the circle this way, okay? So let's start with number 3. These are gonna be your 4 quadrants. Okay, so first thing that I want you to do is sketch this vector, 8, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. Doesn't have to be perfect, just do a little sketch. Okay, you should have learned in your, do you remember SOHCAHTOA? You remember that? Okay, in SOHCAHTOA, that if you need to know an angle, you can always solve for the angle as long as you know 2 of the sides. So without getting super into it, 8 is this side length here, so label that with an 8. 5 is this side length here. And your theta is this center angle that is formed with the positive x-axis. 8 is the center angle formed by the positive x-axis. So would I choose SOHCAHTOA or TOA? if I want 5 and 8 to both be in the equation?
No,
I have no idea what.
Okay, I want 5 to be in the equation. Is that hypotenuse, opposite, or adjacent?
adjacent,
Opposite.
Okay, 5 is opposite. What about the 8? Adjacent, so if I want adjacent and opposite,
Oh,
I want TOA.
good job, girl. Good job. Good job, V5.
Okay, so I want you to write down on your paper, tan theta equals. And then it's opposite over adjacent, which would be 5/8. Okay, now, real quick, before we go on to solve it. Before we go on to solve it, isn't tan also y/x?
Yes, ma'am.
And what's the y? 5, and what's the x? 8. So if you hate the triangle stuff, y/x is the same. So usually that's how I'm gonna have us do it, just because we're not going back into all the triangle stuff. Okay, but you're always gonna put y/x, you're always gonna pick tan. Okay, so from here, we wanna solve. How do I cancel out the tan in the front? Do you remember? The tan with the little -1. So do tan -1. And in your calculator, you don't need to use the fancy fraction, but you can if you want. Second tan of 5/8 gives me 32 degrees. So theta equals 32 degrees. Now, 32 degrees is measured from the positive x-axis, which is here, around this way. So that would also be considered your direction. So in quadrant 1, your reference angle and your standard position direction are the exact same thing. That's not always the case. Let's look in quadrant 2. Okay, in quadrant 2, will you sketch your vector, which is going to be -2, 5. -2, 5. So left 2 of 1, 2, 3, 4, 5. We're gonna always start off with tan equals y/x. So what will my equation say? Tan theta equals what? Give me the numbers. y/x.
5/2.
Good. Now, little fun fact, you can also ignore the negative here, so just pretend it's not there. We're gonna just put 5/2. Then how do we solve that in the calculator? Inverse, very good. So I'm gonna do inverse tan on both sides. What is the inverse tan of 5/2? Okay, it comes out to 68, and we're gonna always round to whole numbers on this, so we're gonna keep it at 68. Because it's 68.1, yeah? So 68 degrees. Okay, but here's the problem. 68 degrees is measuring the side in the triangle, which is right here. So watch my picture here, if this is 68, is that touching the positive x-axis?
No.
No, then it's not the direction. The direction has to be measured starting here and rotating this way. That's direction. So how can I find the direction if I know that the purple part is 68 degrees?
subtract from 90.
Not subtract from 90, subtract from, how much is this? All the way around? 180, then I can minus the 68 off, that'll give me direction. So anytime that you're in quadrant 2, you're gonna do 180 minus the theta. And that'll tell you the direction from the positive x-axis. So now will you do that with r theta? What's 180 take away 68 degrees? 112 is your direction. Because remember, direction is always measured starting here and then rotating around to your vector. All good? Okay, 2 more quadrants left. Take a look at number 5. Sketch your vector, please. -4, -2. So we're going to the left, 1, 2, 3, 4, down 2. In order to find our angle theta, we're always going to use tan equals y over x. And in this case, ignore the negatives. What's my y over x going to be? What fraction? 2/4, ignoring the negatives. Don't bother to reduce, because what are we going to do to cancel out the tan? Inverse tan. In your calculator, will you inverse tan on 2/4? Round it to a whole number. How many degrees do you get for that? Okay, 27 is correct. Here's the problem. So put 27 in your reference angle position. 27 degrees is only measuring the angle of the triangle, which is here to here. And where does my direction have to start from? The positive x-axis, yeah, which is here. So I have to start here. It's right on the boundary, and I have to rotate this way. So if I want to start here and rotate all the way around to my angle to find the direction, what formula would I need to do here? Can I do 180 minus again? 180 plus, because look, I have to start here, go the full 180, and then plus 27 more. Does that make sense? So put in the blank 180 plus theta if you're in quadrant 3. 180 plus theta. And then do it with our theta, which was 27. What's 180 plus 27 degrees? 207 is the direction for this question. Okay, we have 1 more quadrant left, last one. 10, -3, sketch your graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Tan theta equals what?
Mm-hmm.
3/10. Remember, we're dropping the negatives. And then to solve to get rid of the tan, we're going to do second tan in the calculator. So second tan on 3/10. What do we get for that? 16.69, which we're going to round to 17. Very good. Okay, now here's the problem. 17 is finding you how many degrees are in this triangle. But where do I have to measure direction from? The positive x, which is here. So if I have to start here, I can't go this way. That's a negative angle. We're not doing those. You have to go the long way around. So if the entire circle is 360 degrees, and this part is 17, how can I find this part? 360 take away. Very good. So in your standard position formula, put 360 minus theta, and then do it with our theta, which is 17. So 360 take away 17, what do we get for that? 343. Okay, overall, does that make sense? Okay, will you pull out your Chromebooks? We're gonna do 2 examples off of that together, and then you'll have the rest of class. We're not doing the last page of the notes today. Anybody need scratch paper? Not big enough to worry about.
Just give us a mirror and
Do you guys need paper over here? Paper over here?
You're messing it up. Lock in, lock in, lock in.
Paper over here? I'm not.
Can you?
Looks like.
You remind mom. Stop talking. You're not talking about that.
This looks. It's very cool though. All right, go into the first question.
Yes.
Did you get that from the house bunny?
No, I just always do it.
Oh.
You need to stop.
Okay, go into your first question. Do y'all see the assignments?
Oh, I think so. That sounds great.
Down. You like the first one?
Okay, yeah, just very first one. Okay. Actually, let me give you mine as well. Okay, listen up, just real quick. Okay, first example, your original vector is 2,1 and you want 5v. What's gonna happen to the length of the vector? Will it get longer or shorter?
Longer.
Longer. Will it point in the same direction or the opposite direction? Same, because it's positive. So what is 2,1 times 5?
10.
10, what?
10,5.
Okay, so look, watch, you're just gonna drag your vector to make it longer until it gets
To 10, 5. So here's your original vector. And now here's your long vector, then write the coordinates in the box below.
So you're gonna drag it to be longer and then put 10,5 in the box below.
Easy? You can do it?
Yes.
What if it was half of that? Would the vector get longer or shorter? Shorter. What if it's negative a half?
It'll go opposite way.
Shorter and opposite way, that's right.
Sophia.
Wow, this is getting weird. Okay, last one we're gonna do together is second from the bottom. Okay, the only reason that we're gonna do one of these is because it's multiple steps. So if you will please pay very close attention, then you should be able to do the last problem set on your own.
Okay, it says, my initial point, everyone, this is the second to last question, is 6, 0, and the terminal point is 0, 2. So you are going to click and drag,
Starting at 6, 0, and you're gonna stop at 0, 2.
Okay, why do we do that?
just to draw the vector. So it says your vector starts at 6, 0, and it terminates or stops at 0, 2. Okay, then your instructions change. Move the vector so that the tail is at the origin. The tail is the dot end. So
Once you've drawn your vector, you're gonna drag it.
like that. Okay, if you need help, raise your hand, and now you should have 3 boxes below if you did it correctly. So start at 6, 0. Oh, hold on, don't click. Yeah. See what I do. Okay, go to 6, 0, and then drag to 0. Yeah, right. Okay, then click and drag it to where the dots are. Okay, everybody good? Okay, listen up. Okay. It's gonna ask you for 3 things. You know how to find all 3, or just doing them all in the same question? The first one is the X comma Y. What is the XY of that arrow that you just drew?
-6.
So hold on. No, you gotta count from here to here. So it's 1, 2, 3, 5, 6. So that'd be -6. And then what's the horizontal component? 2. So it'd be -6 comma 2. Okay, your next thing is asking for magnitude. That is the length
That's where you do a squared plus b squared. Do you care about the negative?
No, ma'am.
No, so you would do, for magnitude, 6 squared plus 2 squared, and then square root it,
Okay, let's think about this.
okay? So 6 squared is how much?
36.
36, 2 squared is?
Four.
So 36 plus 4 makes how many?
4.
So I want the square root of 40 in that box.
4.
What?
No, it's 6. 6.2.
Just keep square root 40, actually. Okay, and the reason why is because it says the exact value, right? Okay, last thing you wanna find is direction, and direction starts off with tan theta equals y over x. And then what is my y over x?
2 over 6.
Okay, 2 over 6, then how do I solve that?
Inverse.
Inverse. So inverse tan on 2 over 6. What is my theta equal?
18.
18, is that rounded? Okay. Now, here's the problem. If you put 18 degrees, it's gonna count it wrong because that's measuring this distance. So I want you to look at your notes. What quadrant is that vector in? 1, 2, 3, or 4?
2.
2, and what is the 2 formula?
180 minus 10.
180 minus theta. So I'm gonna do for quadrant 2. 180 minus theta, which is 180 minus 18, which is how many?
160.
162. So listen, the first thing you found is called the reference angle. And the second answer that you're giving is the direction. But you have to find the reference angle to get to the direction. Okay? Last thing I'm gonna have you do before I let you work is draw yourself a little grid of your direction formulas. So in quadrant 1, you keep it the same. What was the formula for quadrant 2? We just did it. 180 minus theta. What about quadrant 3?
180.
Plus theta. And then what about your last one?
360 minus.
360 minus. So just look at what quadrant your vector's in to finish off your direction. Oh, you're in, you need to be in.
What are we doing there?
Oh, okay. And now try it again. and it should be- But you're doing it. Yes, take the pass, huh? Sure, take the other pass. If your answers aren't coming out right, check your mode.
My name is.
I think you stepped on your little, lip.
Then you know you like mine singing, don't you do that anything else? Okay. What did you do for this one? I don't like where. She got mad. Say, mama, that's not even huge. Yeah, people be having spiders on their eyes. If you see Carly's jumping, they just really fight.
Yeah. Just stick your hands in the window or something, you know?
Cause now she look like a little angry bird.
Anaya, that girl. Be sweet to your friend.
That girl. Oh, they look cute though. But I don't got no eyebrows, so I couldn't. Get lit, go, why not? You wanna have.
Like, I don't want to come false.
Hey, What are you talking about? The eyelashes? Oh.
Or like when you're talking to someone and it's just.
Yes. You can see the glue.